Morning, everybody. Sorry about this. My computer crashed just before we booted everything up here, so I had to go and restart everything. So if you can give me a green check to make sure you're with me and you're online. I know some issues were happening with Blackboard and the live feed this morning, so it kind of looks like things are going okay so far. Minus my computer not running like it should. Maybe it's just, maybe there's something in the air. Maybe the sun sent off a solar flare or something that's messing with all of our computers. Excellent. Everyone seems to be with me in chat, and if you're viewing the live feed, you can hear me. So I think we're doing okay. We're gonna jump into some of the questions and work, and I just want to talk about the lesson that you were watched yesterday or today, hopefully. And we're going to do some problems and just kind of try to wrap our heads around the tangent ratio, and then we'll move on from there. So, how old is the universe, Alex? That's an interesting question. I don't know. Nobody knows, no. We have estimates, but we don't know for sure. You can Google it. It'll come up. Be lots of good information on it. So Unit 8, Lesson 1 is called Using the Tangent Ratio to Calculate Angles and Lengths. And I intended to go back and get rid of this table at the top. It was kind of like an in-class activity I used to do, but I didn't. So you can just ignore this top portion, the construct your understanding. If you did it, then that's fine. There's nothing wrong with doing it, but I didn't really want to spend a bunch of time on it. So what I did, right in the lesson, we start with the tangent ratio. So I guess the most important sort of idea that's going to help you be successful in this Unit 8 is being able to label the sides of a triangle, the opposite, the adjacent, and the hypotenuse. So the easiest one to identify is always the hypotenuse, because it's the longest side of a triangle and it's always across from the 90-degree angle. So if you can do that one, you're winning the battle. And then it's the opposite and the adjacent. So the tricky part comes when we're dealing with a triangle like the one here. We have three angles. We have angle A, we have angle B, and angle C. So angle B is a 90-degree angle, and angle A and C are the two angles we're kind of dealing with. So when we talk about the sides of a triangle, we're talking about, first of all, locating one angle. So if we are talking about angle A, then we're measuring all the sides from there. If we change and then start talking about angle C, well, now the opposite and the adjacent sides have switched. So that's kind of where we run into some issues. But once you've kind of get the idea of the opposite, the adjacent, the hypotenuse, you should be okay. And this tangent ratio is just kind of a way to kind of ease into that. So I'm just going to remind myself a little bit about what was in this lesson, because I did it before Christmas, beginning of December. So we talked about the sides of a triangle, and we determined the angles and labeling our sides from angles and calculating side lengths and angle lengths, and then we had a couple problems. Okay, perfect. Did anybody have any questions from the lesson? Something that maybe didn't get explained very well, or just you're confused about? Because I'd be happy to go through that. I see that Abby, you have questions from the learning guide, which is great. We'll definitely go through a few of those. And I guess today we're going to go through some questions, and it's kind of, you remember when we did exponents, it was a bit of learning how your calculator works. We're going to kind of do the same thing today, learn how your calculator works, because everybody's calculator is going to be a little bit different. You need to make sure you are comfortable with how your calculator works. So I hope you guys had a chance to go through the video. We checked before, and it seemed like there was a bunch of views on the video, which was great. So a bunch of you did have a chance to go look at it. I see Jade might be typing a question. I'll give you a second, Jade. And what I'm going to do is I'm going to go to some questions from lesson 1. So these are the questions that are in the course, and I had it pulled up but then it crashed. So if you are in the course, this isn't from the learning guide, this is from the lesson 1 tangent ratio practice assignment. So that's what this is. So I just wanted to mention a few things about some of these questions, and then I'll go through some answers, and then maybe we'll look at the learning guide about midway through, and we'll kind of work through some stuff, and hopefully everybody will be on the same page. So determine the tangent ratio rounded to 4 decimal places by using your calculator. So I just want to look at number 1. We're talking about a tangent ratio, and it's important to understand what a tangent ratio is. So you'll hear me say just tangent or tan as an abbreviation for tangent ratio, but what it is the ratio between lengths of sides on a right triangle. So all of this trig stuff we're talking about, you must have a right angle triangle. If you don't have a right angle in your triangle, you can't use any of the sine, cosine, tangent. Of course, we've just looked at tangent so far, so that's all we should understand. Now, when we talk about ratios of sides, what we're just saying is if you have an angle in the corner of a triangle, then you know one side's going to be some ratio compared to another side. And we're talking about the tangent. Remember, the tangent is the length of the opposite side divided by the length of the adjacent side. So if you have a right angle triangle, here's my right angle. This is the angle I'm talking about down in the corner here. We'll call it A. This is my opposite side. This is my adjacent side. So depending on what this angle A is, we can think about, you know, the ratios of the sides. Now, when I learned this stuff, I had a really old school teacher. I remember it was grade 10. And again, when I started teaching, when I was doing my practicum, again, I had a really old school teacher, and they insisted for the first few classes we used trig tables. Now, if you think about the ratio of 2 sides of a triangle, angle A in the corner here, it has to be between 0 and 90 degrees, because if it could be anything. It could be 1 degree, it could be 2. Once you get to 90, you already have a 90-degree angle, so now you have 3 angles in a triangle. So you could have an 89-degree angle for angle A, or you could have anything from 0 to 89 degrees. So if the ratio, it doesn't matter, you know, the length of the sides, we're just talking about a ratio, what we can do is we can make a table. Now, this is a bit difficult to see, but you might be able to. This is all the angles from 0 to 90 degrees. You can see angle on the first column here, you have 0, and then angle 90 degrees down at the bottom. So what your calculator is doing when you press the tangent button in your calculator and you put in an angle, your calculator is not doing magic. It's not pulling numbers out of thin air, or connecting to the internet and doing complex calculations. It just has this table in its memory. That's it. These are all of the choices. You literally have anywhere from 0 to 90 degrees, anything in between. So this is a trig table. Your calculator has this in its memory. That's it. It's not magic. It's not something special that's going on. Students a lot of times lose sight of it. You're so connected to this calculator, you put in a number, it spits out a number at you, and you're like, oh, great, that's the right answer. How did I get it? I have no idea. Well, it's just saying the ratio of sides is this, and there you go. So I'm going to jump back to the lesson. How did they do math to find those numbers? That's a great question. Let's pick a really easy one. Like 45 here, 45 degrees. You can see that the ratio is exactly 1. What does that mean? Well, let's draw a triangle. Here's my right triangle. I have a right angle in this corner, and I have 2 angles, so there's my right angle triangle. Now, this says if the angle is 45 degrees, so this guy here is 45 degrees, what do we know about triangles? Well, we know all angles in a triangle have to add up to 180. So this is 90. So if this is 90, this is 45. This must be 45 degrees as well. So if we're talking about this angle down here at the bottom, and the tangent is the ratio of the opposite side to the adjacent side, well, does it really matter? This is a perfect isosceles triangle. If this is a 45 degree angle, this is a 45 degree angle, then that means this side length is the same as this side length. So if this is 7, this has to be 7. So when we have the tangent as the opposite side length divided by the adjacent, we're going to take 7 divided by 7. That's going to give us 1. So if it's, exactly the ratio of 7 over 7, it's 1. So a 45 degree angle means that we have an exact ratio of 1. And as you get further away from 45, maybe closer to 90 or closer to 0, you end up with numbers that are really close to 1. So that's kind of the way that works. When we have the numbers from this table, all they've done is said, okay, if we have, I'll just pick a random one like 84 degrees here. If you think about what that type of triangle is going to look like, I'm going to have my right angle here in the corner. There's my right angle. And this is 84 degrees down here. So this is, maybe this would be a good diagram. This angle has to be really close to 90 degrees. So if this is 84, the length of this side here, the opposite side, and this is the adjacent side, the opposite side is really, really big. So if this, if we take the tangent of 84 degrees, the opposite side is, we'll say that the adjacent side is 1. Well, the opposite side has to be 9.5144 divided by 1. So that's kind of all it is. It's just, doesn't matter how long those sides are, the ratio of the sides is going to always be the same. I hope that kind of sheds a bit of light on what's going on here. I do want to move on to using your calculator. So yeah, it only works with right angle triangles. That's kind of the catch with all of the trig identities we're going to learn. So I'm going to jump back to the question. I want you to use your calculator, and I'm going to use this fancy trig table here because it's kind of fun, I think. So the first question here is the tangent of 77 degrees. Now, I want you to plug it into your calculator and see what ratio it gives you. Then I'm going to look on the trig table and see what the actual ratio is according to the table. So I might have to, round a little bit. But if you have a TI-83, I think Jade asked TI-83, you're going to go tangent 77 and then enter. Some calculators you have to do the 77 and then hit the tangent and then it'll give you the ratio. Some calculators you're going to do the tangent button first and then the 77 and then enter. And we'll go from there. So I don't know what it is, Taylor, but I'm going to look right now. So I'm going to go to my tangent table, and we said that we wanted to find the tangent of 77 degrees. So what I'm going to do is I'm going to find an angle, 77 degrees right here, and it says that the ratio of sides, if the angle is 77, must be 4.3315. So let's go back. Tangent of 77 degrees equals 4.3315. And remember, that is just the ratio of the opposite side divided by the adjacent side. So it doesn't matter how long they are, it's just once you divide them, you go from there. Okay. So two things are happening here. Sorry, I'm just kind of reading chat. Jade, your calculator isn't in degree mode. You're measuring angles in radians, which is something we can easily fix. And then Alex, you're a step ahead of us, which is the opposite, working backwards, which is really good. So Jade, what you're gonna have to do, I don't have my T83 with me, it's in my office. There is on your T83 Jade, it's either a menu button or a mode button. It's kind of up at the top left side. And then it's gonna bring up a screen with like 0 to 1 and then a bunch of other things. And then on one of the lines, Jade, it's gonna say DEG, RAD, and something else. I forget what else is there. And what you're gonna have to do is, you're gonna have to move your cursor down, Jade, until it's over DEG, and then hit enter. So you need your calculator to be in degree mode. Most of your calculators should automatically default to it. I have my little Casio here, or Sharp, sorry, and at the very top of your calculator window, it doesn't matter what calculator you have, well, I guess it might. You should have something that either looks like a D, or a DEG, or something along those lines. Did you get it, Jade? Oh, thanks. I assume you got it. Try it again, and it should work. So one super important thing that Jade just ran into was we can measure angles in degrees. We can say, okay, 0 to 90, 0 to 100. We can do 360 degrees. We can measure angles in another form using radians, and it's kind of based on a different set of values. You'll move into radians in grade 11 and 12. So your calculator can measure angles in different ways. You can do these problems in degree mode or radian mode. There's probably another mode that I'm forgetting. The height button. Taylor, we won't worry about the height button for now. That's like a grade 12 or university math concept. So you have to, and when you guys sit down to write your provincial or even the test, I'll come through and make sure everybody's on the right track with your calculator, but your calculator has to be in degree mode. If your calculator is in radians mode or RAD mode, it's going to give you the answers in radians, which would be great, but we don't know how to use radians yet. So all your answers are going to end up being wrong. So that's what happened to Jade. Sometimes your calculator will just default to radians, or maybe your older brother or sister was using it and they were doing calculations in radians. Your calculator has to be in degree mode. So if you're getting this 4.3315, it's all good. You don't have to worry about it. Alex, they do have that already. There's something called Wolfram Alpha, and you can literally just put in the question and it does the whole calculation for you, showing all the steps. It's a pretty cool program. You can just access it online. Let's take a couple more of these, and we'll just make sure everybody's on the right track using their calculator. So tangent 77 we did. Tangent of 45, we know what that is already. That's 1. And that is a great way to test if you are doing things correctly and if your calculator is working correctly. If you take the tangent of 45 degrees, it has to be equal to 1. So if your calculator is in the incorrect mode, it's going to give you some bizarre answer. So if you want to check to make sure your calculator is working properly, you're in the right mode, you can go tangent 45, enter, or tangent 45 equals, and if it's 1, then you're doing okay. Alex is called Wolfram. I can write it down here for you. Wolfram Alpha. It's a pretty cool site. Lots of sciencey and math stuff in there. You can put in full equations and it'll give you full solutions. I think you have to pay. You give you like one free one or something, or maybe it gives you a couple steps and then it hides some. But anyways, it's kind of fun to play around in there if you're kind of a math geek like I am. All right, so we did the first two. The tangent of 89 degrees, I'm going to go back to my tangent table here. I'm going to go down to 89 degrees, and that's going to be a really big ratio, so 57.290. Your calculator is going to tell you something similar to that. What did I say? 57.290. Yeah, 57.2, that's good. And your calculator is gonna do some rounding, and this table that I'm looking at is rounding as well. So if you're close, then you're doing okay. All right, so if anybody's having issues, do you wanna just kind of give me a red X or just do something? I need help, I don't know how to use my calculator, because we wanna get that out of the way now. It's just like the exponents thing. Everybody's calculator is a little bit different, and I just want to make sure we've got this mastered, because unfortunately on a test you're not allowed to just come in with a trig table, which would be pretty easy to do and just use, but they want you to use your calculator. So if you're having issues, you can give me like a calculator model and I can see if I can find how to use it or go from there. So question from the learning guide. Okay, Avery, we'll get to that in just 2 ticks here. And Abby, okay, I think we're okay. All right, the next question, I just want to go through a few of these and then we'll go to the learning guide for a little bit, okay? So determine the measure of each angle to the nearest degree. Now, when I talked about the ratio of sides, we had this trig table, and your calculator has this trig table in its memory, and you say, 45 degrees, and it says, okay, the ratio of those sides is 1, because it's 45 degrees, it's an isosceles triangle, your ratio is going to be 1. Awesome. So your calculator works really great when you give it an angle, and then it gives you the ratio of sides. But what happens if you want to work backwards? You want to give it a ratio of sides. Say, you know how long one side is, you know how long the other side is, and then you want to figure out what the angle is. So your calculator knows it's using the tangent sort of table, but how do you tell it to work backwards? Instead of giving the angle and then giving the sides, you give it the sides and it gives you the angle. So that's what this question is asking us. So the way that we need to do this is using the second function of your calculator, the inverse tangent. So we've talked about the inverse before. If I had like 7, the inverse of 7 is 1 over 7. It's the flip or the opposite of 7. So that's what we're going to do with our calculators right now. So this is saying the ratio of sides, this is the opposite side, remember? The length of that, the opposite side divided by the adjacent side, is this 0.6532. What is the angle? So on my calculator, I have the second function, I have to hit the second, then I hit the tangent button, and then I enter my number 0.6532. And then I go equals. What I'm going to do is just look at the trig table real quick here. I'm going to try to find 0.6532. So here's 0.64, here's 0.67. So I know it's somewhere between 33 and 34 degrees. I'd have to estimate it at like 33.65. It's probably like 33.1 or 33.2 would be my estimate. I see a few people putting angles in, which is awesome. We're getting 33.15. I like that because that was close to my estimate. So second tangent, Abby got the same thing, perfect. So I want to make sure everybody knows how to use that second function on your calculator. Second, some calculators will be shift. Jade, you're using a T83. I think you have a second button, like a 2ND button as well. So my Sharp has the second function. Taylor's is one of the backwards ones where you have to put in the number first and then second and then the tangent. That's fine. Some have a shift. Perfect. So yeah, this could be a shift button as well. Okay. Let's do the next one, 0.7. I'm going to use my table, and you guys can use your calculators. So I get 0.7 is 35. So it's going to be really close to 35. So we're getting 34.99. Yeah, we'll just round that to 35. And then degrees. These are all measuring angles, so we'll go degrees. Perfect. I think I'm just gonna, pause there for a second. So that's all we're doing with the tangent ratio. It's just a table, and I know, Abby, it seems kind of weird that we can't just use the tables, but it's kind of technology, right? Your calculator has the ability to memorize that whole table for you. So, why not use that technological advantage and just plug your numbers in, and it is what it is. If you guys want to throw in some questions from the learning guide, I'd be happy to look at them. And then maybe I'll come back and do a few more of these questions here. We can go from there. So the learning guide, right angle, trigonometry, learning guide, tangent ratio. So basically we're talking about 11 questions here. And I know that Abby had some questions, Alex has a question, and I think Avery had a question as well. So if you guys want to put those in, that'd be awesome. Yeah, Taylor, I'm going to go through a few questions, but I just wanted to make sure everybody was on the right track with their calculator. I don't want to just do the learning guide for you because you need some practice. So we can go from there. Page 2, question 11b, 7b, page 1. Let's start with 7b, page 1. Okay, what is the tangent ratio to 4 decimal places of the following angles? So we're given an angle, and then we need to find the measure. So 63 degrees, I'm going to use my calculator for this one. I'm going to go tangent 63 equals, and I end up with 1.96261. And it asks for 4 decimal places. So 1, 2, 3, 4. I don't know if I'm missing something here, Abby. 1.96261, unless I've made a mistake, perhaps. So we just lose the 1 here, and 1.9626. That looks like 4 decimal places to me. And I'm happy with that. Avery, I answered your question. Awesome. We did 36 by accident. A little dyslexia. I do it all the time. Like, honestly, all the time. So when you're doing like calculus questions that take 3 or 4 pages and you mix up a set of numbers, it's a little bit of work to go back and fix it all. So page 2, question 11b, and then Avery is asking for 11b as well. So let's go to question number 11 here. 11b. This is kind of something that's not necessarily funny, but it's interesting when we take a triangle and we kind of rotate it to perhaps a perspective that you're not used to. The right angle is kind of up at the top, and then you have some weird things happening. Students get kind of thrown off by it. It's really interesting how that works. So remember, when we're dealing with the tangent ratio, we need to figure out what angle we're dealing with and then measure our sides from that angle. So in this case, I'm trying to find this x. I'm trying to find how long the side is here. So we're trying to find out how long it is. And we've been given one angle. So the angle we're given is down here in this corner. So what I need to do is label the sides of my triangle based on the angle I'm given, the information I have. So the first thing I'm going to do for every triangle is figure out where my 90-degree angle is and figure out where my longest side is, because the hypotenuse is the easiest side to find. So I have my right angle in the top corner here. My hypotenuse is going to be across from it. So I'm going to label this as my hypotenuse. That side is my hypotenuse. Okay. The other two are the opposite and the adjacent, and these can get a bit tricky and kind of easy to get mixed up because you might switch angles in a question. So you might be talking about one angle for one part and then another angle for a different part of the question. So a good way to think about it is start at the angle you're dealing with, so in this case the 35, and if you draw an arrow from that angle across the triangle, that will give you your opposite side. It is opposite your angle. And if you think about this x here, I have a triangle, and I have this side here and this side. The hypotenuse has already been taken, so I know that this is the adjacent side, and the adjacent side makes up the angle. It's a lot of mess in there. Here we go. So, all right, I can go from here now. So I know that the tangent of the angle, and I use the Greek letter theta, the tangent of the angle is going to be the length of the opposite side, which I just abbreviate as OPP or opposite, divided by the length of the adjacent side. And again, I'm going to abbreviate the length of the adjacent side with just ADJ or adjacent. Okay, so the information I know. I have the tangent. I have 35 degrees is my angle. So I'm just plugging that information in. The opposite side's length is 12, and the adjacent side, I don't know, it's x. All right. Now I know that the angle 35 degrees is important. It can tell me the ratio of those sides. As soon as I know the angle I'm dealing with, I can figure out the ratio of my sides. So I can go from that, figure out what the length of the opposite compared to the length of the adjacent is. And then I'm given this other information that, oh, the adjacent side, I don't know, but the opposite's 12. So I can go from there. So what I'm going to do is I'm going to look at my trig table again. You guys can you can plug it into your calculator, but what we're doing here is the basic calculation. Take the tangent of 35 degrees, and that's going to calculate for you, or just access that table and tell you the ratio of the sides, what they should be. So I go in, I find 35 degrees, oh, I already used 35, 0.7002. So I go back to my learning guide. So this is 0.7002. So that is the ratio of the sides. I know one side is 12 and one side is x. I guess there's a couple ways you can think about this. You can think about this as 0.7002 over 1 is 12 over x, or you can just think of it as those sides have to be that ratio. But either way, you need to get x by itself. So we want to end up with x is equal to something. Now, x is on the bottom, it's in the denominator, so I want to bring it to the top. So what I'm going to do is multiply this side by x, because x on the top and bottom are going to cancel out. If I multiply the top of one side by x, I have to multiply the top of the other side by x. So I end up with 0.7002 times x is equal to 12. And then I'm going to take both sides and divide by 0.7002. So it's going to divide out on the left, and I'm going to be left with x. And then 12 divided by 0.7002, or 12 divided by the tangent of 35, is equal to 17.1. And that's a length. I don't have any units, so I'm just going to go with 17.1. So that's kind of the idea here. I guess there's a different way I could have solved the problem. I could have done it without actually calculating the tangent of 35 until the last step. Maybe let's just go back and I'll just show that, because I might do that way sometimes. So I'm going to just restart the question here. I'm going to take the tangent of 35 degrees, some ratio, is 12 over x. I'm going to multiply both sides by x, so I get x times the tangent of 35 degrees is the length 12, and then I'm going to divide both sides by tangent 35. So I'm just doing the exact same thing. I guess I can write in a step here. Just the exact same process, except now I have x is 12 divided by the tangent of 35 degrees. And you can just plug that into your calculator. You can go 12 divided by 3510, or just depends on how your calculator works, but you should end up with the same answer, x is 17.1. What is the smallest calculable length of distance? I think Abby is exactly right. You can do infinitely small numbers. So you can't calculate an infinitely small thing. It's just kind of, if you can imagine this, Alex, if I started with a number and I went 0.001, that's a pretty small number. Okay, let's add another 0.0001. And then imagine if I took a whole, book's worth of paper and I just put 0.0000000. And I could just do that until the end of time, and then just 2 seconds before I passed away, I just wrote a 1, and I had like a Googleplex amount of zeros in there. That would be a small number. So I don't know if that answers your question. It's kind of an interesting question, I guess. Isn't like Planck length? Yeah, so yeah, you can get really small measurements. There's no limit to how small you can go, though. And Alex, that's kind of the basis of calculus, to be honest with you, is taking infinitely small slices of something and looking at how it kind of adds up. So if you are on that track, that's what calculus is kind of all about. It's interesting that you would ask that question. All right, is there anything else from the learning guide? A Planck length, 1.6 times 10 to the negative 26 nanometers. A nanometer is times 10 to the negative 9, so that's 0.00000000001. That's a nanometer. I guess that would be meters. And then the Planck length is 26 zeros in front of that. So if you can imagine writing 26 zeros and then the extra 9 zeros, that is what a Planck length would be. Now you're talking about like an atomic scale, the distance between atoms, or even smaller, like the nucleus of atoms, I'd bet, with a Planck scale. Very off topic, but I like it. All right, so that is that stuff. Nobody had any pressing questions. I think it's pretty straightforward. One thing that's really cool is that we're going to talk about the sine and cosine ratio in the next lesson, lesson 2. And it's the exact same stuff, except you're just dealing with different sides of triangles. So it's if you really understand the tangent ratio well, you understand what's going on, you kind of wrap your head around the length of sides and how you're dividing them, and it gives you an angle. If you can wrap your head around all of that, sine, cosine, the exact same thing. It's like, if you really understand tangent, then sine and cosine are going to be a breeze. And if you're kind of working through the tangent, you kind of don't get it, but you understand how to do the calculations, you can do some of the algebra to solve for the missing sides, then you're going to have a little bit more practice with sine and cosine, and you guys will be well on your way. So there you go. That's kind of it. I guess the hardest stuff is the algebra that we've done here. We can go with that. And then I have like 10 minutes left. I'll just kind of give you guys a head start on the sine ratio. Again, I'd like you to go to the course and watch the second video, as well as finish off the first 11 questions, which really isn't that much. It's like, in terms of the amount of time, it would take you. It'd probably take you maybe like 5 minutes to do these questions. So it definitely won't take very long. And then the sine ratio. So if you haven't watched the video yet, that's fine. I'm just gonna maybe kind of talk about it like I talked about it in class today, just kind of extend what you know already. So if I took a right angle triangle, here's my right angle triangle, here's my right angle. I have this angle A in the bottom. So here's angle A. We talked about today labeling our sides. So this is the opposite side, this is the hypotenuse, and this is the adjacent side. So for the tangent ratio, the ratio of sides, tangent of angle A, it's going to be the opposite side, the length of the opposite side divided by the length of the adjacent side. The only thing that changes for the sine ratio, instead of talking about the opposite and the adjacent, we're now talking about the opposite side. And instead of dividing it by the adjacent side, we're talking about the opposite over the hypotenuse. That's it. And then when we talk about the cosine ratio, the cosine of angle A is going to be, well, what's left? We have the tangents, the opposite over the adjacent. We now have the opposite on the hypotenuse. Well, what are the only two sides that are left? Well, we have the adjacent side divided by the hypotenuse. So we have three trig functions because there's three possible combinations of sides we could be dealing with. So that's exactly it, Taylor. This trig stuff, the questions can get a bit tricky in terms of the algebra, but they're always the same. You're always going to have, some sides, and the problems in the last section can get a bit tricky. You might have to do a couple steps, but if you can look at a triangle, you can label your three sides based on an angle, or if you're given two sides and asked to find an angle, as long as you kind of understand all of this stuff is, just based on the idea of dividing the lengths of sides and getting an angle. So I showed you a tangent table to figure out all of the angles, or vice versa if you're given a ratio working backwards. Tomorrow, we're going to come and we're going to talk about the sine, which is just going to be a different table, but the same idea. And then cosine is going to be the same thing again. So I'm going to leave you guys there. I promised you guys some time to work through those problems kind of in class today. So if you haven't gone through the learning guide, then you can do, up to question 11. I don't want you guys to worry about doing the sine ratio questions from the learning guide for homework tonight. What I want you to do is watch the video on the sine and the cosine ratio, and then we're going to spend time in class tomorrow going through those ideas again. So there you go. Some questions. Mr. Bourne, do you like supersolids? I don't know enough about supersolids to comment on that. Chrome stopped working. We're okay now though. And will we get to work with Klein bottles in science? I don't even know what a Klein bottle is. So yeah, I don't know what to tell you there. Probably not though. We might have a few labs where you guys get to come in science and mix some stuff up and do some interesting things, but most of our stuff will be based online because not everyone can come in, which makes it a little bit difficult. So a one-sided bottle. Still have no idea what that is. I'll look it up. I don't know that I've ever used one before. All right, so homework is not doing problems. Right now you have about 10-15 minutes to go through the first 11 questions in your learning guide, and then tomorrow we're going to go through the sine and cosine questions in the learning guide and then some extra problems, and we'll make sure everybody's on the right track, and I'll leave you guys there. Thanks very much, and remember we're cross-country skiing on Friday. I am pumped. I've cross-country skied officially once in my life. I'm excited to learn how to do it properly because I just kind of went out and did it. I wasn't very good. So Yeah, so homework is to only watch the next video. I'd love to see you guys cross country skiing on Friday. I'm coming out, I'm excited, and we'll see you tomorrow. Thanks.